For lesson 1.8, our topic is two-dimensional figures. We're going to start out with some vocab. It's really not too complicated, this vocab. Our first definition is a polygon. I'm going to read it to you. It says, it's a two-dimensional figure formed by a finite number of coplanar segments called sides that are non-collinear and are joined only at their endpoints called vertices. That's a lot of words just to say it is a shape that has corners called vertices that are made up of points. It has sides that are made up of segments that are straight lines, and it can be as many of those sides as we want it to be. Okay, so it's just a two-dimensional shape with flat edges. That's literally all that says. If we look here in this diagram, we can see we have sides that are segments like GH, vertices, those are like the corners, which are points like vertex J. There's one way to name polygons, and it's kind of difficult because it's just a lot of work here. Do we know what we call a six-sided shape? What do we call a six-sided shape? It's a hexagon, yeah, hexagon. I heard somebody whisper it. So this is a hexagon. And unfortunately, the only way for us to name this hexagon is to literally use all of the vertices. So I have to call this hexagon G, H, J, K, L, M, which is just kind of a mouthful, but we got to do what we got to do. If you do not know the names of those shapes based on their number of sides, I have this little chart down here for you. You definitely want to highlight this, star it, whatever you got to do. You are required to know these names in this chart, for sure. So 3 sides triangle, 4 sides quadrilateral, 5 sides pentagon, 6 is hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 11 hendecagon, 12 dodecagon, and then any other amount of sides, we just call it like a 13gon, 14gon, 15gon, and so on. Questions there? Definitely need to know. Will show up on your test for sure. Okay, so then let's look at this diagram. This is just showing us like what is a polygon and what's not a polygon. So polygons, again, have flat sides. They are totally enclosed. They're connected up, all that good stuff. Some things that are not polygons. If I look over here, these guys have curved sides. So anything with a curved side is not a polygon. Anything that has a gap or an opening in their vertices is not a polygon. Anything that crosses over itself like that is not a polygon. And then anything that has like a piece sticking out of it like that, like a segment that has nothing else connected to it, that's not a polygon. Questions there? It's kind of easier to see what's not a polygon than what is a polygon. Okay, so then let's classify some polygons. One way that we can classify polygons is based on its shape. So depending on how its sides appear, we could have a convex polygon. A convex polygon, by definition, means that if I take the sides of that polygon and I extend them in all directions, so I see I'm extending these sides out, then those extensions will never cross into the center of my triangle anywhere in here, okay? Those extensions never go to the interior of that triangle. Essentially, it just means it doesn't have any spots where it caves inwards. If it caves inwards somewhere, that's where we call a concave polygon. So concave literally means it caves in. So we can see here that triangle, its bottom part caves inwards. And again, if we go by that rule of extending the sides, you should see what happens here. If I extend this side, we notice it crosses through the interior of the shape. Same thing over here. If I extend this side, it crosses through the interior of the shape. That makes it concave. So that's one classification for polygons. It's convex or it's concave. There's no in between here. The next kind of classification that we have for polygons is based on its congruent pieces. First off, we have equilateral polygons. That word lateral meaning sides. So an equilateral polygon literally means that it has congruent sides. All sides are congruent. After that is equiangular, referring to angles. And that just means that all of the angles in a polygon are congruent. These two things do not necessarily both have to be true. One can be true without the other. However, when they are both true, when something is equilateral and equiangular, we call that regular. So a regular polygon literally means all the sides are congruent and all the angles are congruent. Both must be true. We have to be able to either prove that both things are true or be given that both things are true. Questions on that? If something is not regular, like both things are not true, the word that we just use to like blanket statement that is just irregular, the opposite of regular. So there you go. And then lastly, we're going to talk a little bit about perimeter today. I think we've all seen perimeters of things, right? It's when you take all the sides and you add them together. So if I'm looking at the perimeter of this polygon, this is a nice little warm-up question for us. There's some pieces missing here. What pieces do I need? Do you see them? What do I got to fill in to figure out the perimeter of this polygon? I can highlight what I already have. I have 3, 4, 4, and 6. What are those other sides? What's this one? What's the measure of this? It's 3. The whole thing is 6. This part down here is 3, which means that's 3. What about this guy right here? It's 8. So the perimeter of this polygon here is 3 plus 4 plus 3 plus 4 plus 6 plus 8, aka, I believe it's 28 centimeters. Obviously, the ones that we're going to be doing are a little bit more complicated than that, but that's what a perimeter is. Flip it over to the next page. Okay, letter A. We're going to classify this polygon 3 different ways. First, based on the number of sides, what would we call this? Look back at the last page if you don't remember. That chart's right there for you. What do we call this based on the number of sides? Starts with a Q. Yeah, Caitlin? Quadrilateral. 4 sides, quadrilateral. Convex or concave? Dahlia? Convex. Why? Because none of the lines would cross through the middle. Yeah, none of the lines, if I extended them, would cross through the middle. I can see that if I kind of draw it out here. And I can clearly just see that none of those are concaving in. Regular or irregular? We need 2 things to be true to be regular. Do we have both of those things, Caitlin? Yeah, it's irregular. I have neither one of those things. My sides aren't congruent. My angles aren't congruent. This is irregular. Okay, letter B. Ooh, this is a lot of sides. What would we call this one based on its sides? Look back at the last page. Count those up. Anna? Perfect. 9 sides is a nonagon. Convex or concave here? Caitlin? Why?
Because, some of the sides by the triangle part
Yep, if we extended these lines outwards, we would see that those lines cross through the middle. That's concave. And then regular, irregular. Should just be able to see it, right? We see all those different tick marks. Those are not the same tick marks. This is irregular. Okay, take a minute. Do these two multiple choice ones for me. Okay, what do we get for this first one in letter A? What letter? Be brave. Caitlin. D. Perfect. I know it's a triangle, clearly not a quadrilateral. Convex, because it does not cave inwards. And then it's regular. All those sides, all those angles are congruent. So that only leaves me with letter D. What about letter B? What we got here? Anna. A. Quadrilateral, I agree with. Definitely not a pentagon. Convex, also agree with. It is not concave. Do we agree that this is irregular? Yeah, I think so. I see those sides are congruent. I cannot let that tempt me because I do not know anything about those angles. No info on angles. So if I have no info on the angles, I cannot assume that they are congruent. That has to be letter A there. Perfect. Any questions on that? I think we got it. I won't linger here too long. Okay, here's the last piece. We're finding the perimeter of a pentagon. Go ahead and graph me that pentagon to start out with. Let's do it. I got A, B. Connect those pieces up for me. Okay, so perimeter means I'm counting up the lengths of all the sides. So there should be a couple sides in here that I can get really easily just by counting. What do we see? Do we see the ones that are flat and straight? Those are the ones that we can get super easy just counting. So let's say I know that ED right here is 5 units. And let's say that I know DC right here is 6 units. Those are my freebies, right? Nice and easy. How am I going to find those slanted sides? We've done this once already this unit. How do I figure out the lengths of those slanty sides? Casper? Yeah, Pythagorean theorem, distance formula, same thing, right? So I'm going to give you the first example here. So let's first look at this side right here, EA. I'm going to treat EA as my hypotenuse. I'm going to connect those 2 points up at a right angle so that I get a nice right triangle. From there, Pythagorean theorem just says I got to count up my side lengths, 3 and 3, and use that in the Pythagorean theorem. So 3 squared plus 3 squared equals my hypotenuse, which is EA squared. 9 plus 9 equals EA squared. I'm going to end up with the square root of 18, which I believe gets me 4.2. Any questions how I just did that? Fantastic. Do the next two. We got 2 more sides to find. Anybody want to share their final answer for this segment right here, AB? 1 decimal place is perfectly fine with me. What did we get for this part? Nobody? What do we get? Anna. Perfect. I believe it was like 32 squared or something like that. Square root of 32? No. Yeah, square root of 32. What about BC? Last piece, what do we get? Anna. Perfect. I think that one was square root of 17. And then don't forget, we do have to finish it off. We got to actually find the perimeter. So we're adding all those pieces together. Our final answer should be 25. We're going to add in units, and we're done. Any questions on that?